Hello, today I want to tell you about research work on a ball and plate stand. The ball and plate stand was manufactured by the Feedback Laboratory. It was designed for the different researches and educational purposes in the automatic control systems area. For the controller names, it is used the real-time controller which was set up in the laboratory by the SpeedGod firm. The ball and plate is used for control changing of the position of the ball on the moving surface with the help of the webcam. The surface is fenced by the special bumpers that don't allow the ball to leave the area. The board is attached to the base with the help of the cordon that has two directions of the angle of freedom. The two potentiometric sensors taking place on cordon define the angular position. The changes in the position of the ball are happening due to the tilt of the surface, which is caused by the reaction of the non-magnetic conductive rings on the plate to the variable electromagnetic field. An alternating electromagnetic field is generated in the alternating rings by the current which flows in the ring under the influence of the electromotive force. On and off switching is operated by the special button. The electromagnetic actuator is non-linear, so the regulator should have the compensation of this non-linearity. This stand has an unstable part, the plate. It is so because of the positive communication between the angle and torque produced by the cordon. When the board is titled, there is a force which acts in addition to the board incline so that it continues to fall. The model was created in the IDE MATLAB Simulink. We need to clarify this model with the parameter estimation for the future synthesis of the system management algorithm. During the identification process, we can get the correct results if there is strong regulator. If we use the regulator with the smaller coefficient, the angle changes to the bigger value and goes to the limit during the process of the small changes in the management. We get the negative cordon coefficient in the closed system, but it can't be negative physically. In the opened system, the board goes to the limit very fast. That's why we don't have enough data for the identification processes. There was an hypothesis that guesses that if we move the board with the short impulses from end to the end, each of the impulses will be the change of the initial condition. It means that the system will be opened. The amplitude of those impulses have to be not more than plus minus 2.5 volts for the purpose of the overcoming possible area of insensitivity. The continuance of the impulse should depend on the speed of the plate when the rings approach the coils. We developed the program which allows to realize for the identification of the parameters. We will apply the managing impact and the output of the real object for the model in such a way that output of the model with the process of operation is matched to the output of the object. Now, when the model is checked, it's possible to write the management program. We will roll the ball with the path of square. The control will be digital, the regulator will have two frequencies. The slow one is for the ball, the high one is for the plate. Both regulators are created with the help of model synthesis. The internal condition of the object is measured with the Leuenberger observer.